All right, believe it or not, this is actually our final individual instructional video for the year. The video that I'm going to present tomorrow will be kind of a summary of everything we've done on graphs and tables. And then the following day, when you have your quiz on graphs, I'll have kind of a special goodbye video for you. And then the last week of school will be focused mainly on getting people caught up who have not handed in everything. So for many of you, we'll pretty much be done. I'll have a couple of simple survey questions and things like that, but nothing too consequential moving forward. So let's get to it. Today we're going to interpret box and whisker graphs. Now this is not the first time you've heard the word box and whisker graphs, because a while back when we learned about the 5-number summary, learning about interquartile range, I let you know that 5-number summary is featured in a box and whisker graph. So let's find out about how to read and interpret box and whisker graphs. So here we have a double box and whisker graph, which shows the average ticket price for each team in Major League Baseball and National Basketball Association. And you can see across the board with a box and whisker graph, this information seems to be kind of leaning more to the right. And that's because the box and whisker graph shows our 5-number summary with these 5 dots. So that middle dot is our median, these are our quartiles, and these are our extremes. So you can see, since the majority of the data, in fact almost all the data, is further to the right for the NBA, it lets us know that the NBA average ticket price is more expensive. That makes a lot of sense, since most NBA arenas are about half the size of Major League Baseball stadiums, and NBA plays about half the season. They only play 82 games when the MLB plays 162. So I'm sure that's why they've got to charge more, because they've got a lot fewer games and a lot fewer fans that can be in the stadium at once. So let's take a look at the book's kind of definition on how box and whisker graph works. And so a box and whisker plot or block box and whisker graph represents the data along a number line by using the least value, the greatest value, and the quartiles of the data. Remember that the median will be also considered a quartile, second quartile. A box and whisker plot shows the variability of a data set. So the 5 numbers that make up the box and whisker plot are called the 5-number summary of the data set. So you've heard me call it a box and whisker graph. The book has called it a box and whisker plot. It really can be either, because you graph it and you plot it. So whatever is more comfortable for you. So I can make this a little bit bigger, and we'll take a look at this data. So you can see this kind of outlines how a box and whisker plot uses that data. So you create a box and whisker graph on a number line. So you can see I've got a standard number line that includes all my numbers from the least to greatest. I plot my greatest and my least. I plot my median. I plot my lower quartile or quartile 1 and my upper quartile or quartile 3. And then I create a box to show where that interquartile range is. And it's really cool, because it kind of lets you know that this is where the data clusters. Because if you think about it, this is half the data. And in fact, here's a better image to show you. So about 25% of your data is to the left of the lower quartile, or the whisker. And 25% is your other whisker over here, or about 1/4 of your data. But half of your data is in the box. So when you see a box and whisker graph that has really long whiskers, that tells me that the data in that upper 1/4 or upper 25% of the data, that's really spread out. When you see a tiny whisker, that tells you that the data is really close together. So keep in mind, whether it's spread out or not, that whisker or that section of the box each represents 25% of the data. So when we look at this dunk tank question, it says the box and whisker graph represents the numbers of gallons of water needed to fill different types of dunk tanks offered by a company. So I guess if a company has a really large dunk tank, it would hold a lot more water, and then a smaller, more portable dunk tank would hold a lot less. So it wants to know what fraction of the dunk tanks require at least 500 gallons of water. And the cool thing here is you don't actually need to do any math to figure out that fraction. We know that each section of the box and whisker graph represents 1/4. So here's 500 gallons. It wants to know how much has at least 500 gallons. Well, it'd be anything from here to the right, which is 1/4 plus 1/4. So it'd be 1/2 or 2/4 of the data. Now it wants to know if the data is more spread out below the first quartile, that's this section here, or above the third quartile. So let's look at the two whiskers. Which whisker is longer? Because that's the section that's more spread out. So the answer would be above the third quartile is more spread out. That's where the data varies more. So box and whisker graphs are a great tool for looking at the variation of our data. Now, box and whisker graphs can also have shapes, just like we talked about in the previous lesson. So when most of the data is to the right and the whisker to the left is really long, that lets us know that the data is skewed left. If the box and whisker looks pretty much straight down the middle, symmetrical, then that's going to be symmetric data. And if the data is skewed right, you're going to have a longer right whisker and more clustered data on the left. So let's try. When I look at this is much longer, so I would say this would be skewed left. This is symmetric. This is also symmetric. Even though this is smaller than this one was, they don't all have to be equal like it is with this one. They just need to be about the same on both sides. And here you can see, although the smallest section and in the middle, they were all about the same, this whisker is much longer, which tells me this data is skewed to the right. Okay, so to make a box and whisker plot, what you're going to do first is order the data, find the median, find the quartiles, and then find the extremes. Then you'll draw a number line that includes the least and the greatest values. You'll graph points above the number line that represent the 5-number summary. Then you'll draw a box using the quartiles. You'll draw a line through the median, draw whiskers to the box from the least and greatest values. So we're actually going to do this right now. So a group of friends spent 1, 0, 2, 3, 4, 3, 6, 1, 0, 1, 2, and 2 hours online last night. Make a box and whisker plot for the data. So the first thing I want to do is I want to put my data in order from least to greatest. So I've got 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, and 4, 6. Now, there's a lot of numbers there. Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, 12 numbers, it means between the 6th and 7th number will be my middle. 1, 2, 3, 4, 5, 6. So right there should be my middle. 1, 2, 3, 4. Perfect. That is my median. So my median is 2. Now, to find the middle of the lower half of my data, that's going to be right in the middle of the lower half of the data, will be 1. So that's quartile 1. And the middle of my upper half of the data would be 3, and that's quartile 3. And my upper extreme will be 6, and my lower extreme is 0. So now I've collected everything I need to make my box and whisker graph. Now, since my goal wasn't to find the interquartile range or to to answer those questions, that's just my work. I'm going to really make my box and whisker graph very neat, though. So I'm going to start by drawing a number line. Since my lowest number is 0 and my highest number is 6, I want to make sure I make my number line at least 8 centimeters long, I'd say. So I drew from 1 to 9, that's 8 centimeters long. And now I can go ahead and make my markings. So I'm going to go ahead and mark 1, 2, 3, 4, 5, 6, 7. And that should be enough information because I'm going to go ahead and mark 0, 1, 2, 3, 4, 5, 6. So you can see again I'm using a number line to set up my box and whisker graph to plot my information. And I'm going to plot a dot for my lower extreme. I'm going to plot a dot for my lower quartile or my quartile 1. I'm going to plot a dot for my median. I'm going to plot a dot for my quartile 3. And I'm going to plot a dot for my upper extreme. And now I'm going to form a box around each of these quartiles. and then I'm going to extend to make my whiskers. And you can see right there, there's my box and whisker graph, and you can see that it's pretty balanced over here, but this whisker is much longer, which clearly indicates that this data is skewed to the right. So, which measures of center and variation can be easily identified in a box and whisker graph? Explain the steps you follow to identify each measure. So let's think about that for a minute. We had learned in this unit, or in the last unit, different measures of center and measures of variation. So, when we look at this box and whisker graph, can we identify the mean? And we can't, because we don't have the raw data, we didn't add it all up and divide, so this definitely not. The mean is not available. The median, however, is clear. We know that the median is what separates the box into two halves. Now, you can see that our median is further to the right here. It's not right in the middle of the box, because from quartile 1 to the median is much more spread out than from the median to quartile 3. So we can find the median. I can't find the mode because there's no raw data. So the only item of center that I can see in my box and whisker graph is my median. But I can also find my range, because if you'll remember, the box and whisker graph identifies the upper extreme and the lower extreme. So I can easily subtract 52 and 30 to get my range. I also know that my box and whisker graph shows me my quartiles, the third quartile and the first quartile, so I can subtract 48 and 33.5 to find my interquartile range. However, because I don't know the mean, I cannot find my mean absolute deviation. But you're going to notice that I can get my range, my interquartile range, and my median when looking at a box and whisker graph. All right, guys, thank you for sticking around till the end.